No, like I didn't know it was one.
So last time we looked at types of data, which was discrete and continuous. That falls under what type?
Quantitative data.
Quantitative data. And then there are two types in qualitative data. And what are
Discrete and continuous.
Did we talk about any types of data under qualitative? You can look at the notes.
The types of quantity.
Discrete.
Oh, there's a book guy. Okay. Tyler. I'll remember next time. What was it?
Is it discrete and continuous?
A discrete and continuous fell under quantitative, right? So did we have two types under qualitative? No, right? So we didn't have any types. The reason why I brought that up because we don't have types in this class, but we do have levels of measurement under qualitative data. So we don't say that these are different types of qualitative data, rather this is how we measure things. If you go back and look at the example that we wrote, a bunch of them, you gave me a whole lot of good examples. And for qualitative, I wrote a bunch of levels and I said, these are the levels of measurement. Hair color, for instance, black, brown, blue, gray, etc. So if it is qualitative, the measurement levels would fall into two cases. One is nominal, the other is ordinal. So norm, what does norm mean? Not food.
Normal.
Normal. What?
No,
No, no, no.
that's
Neural.
one. Wait a minute.
It's not num, like.
Name.
In Latin,
No.
that's food.
Yeah, that's the only thing I can think of.
Name. Right. I think it's name or number. If you look at it. So it's a name of some sort. It is a property or it's an attribute. So nominal simply means we don't have any order. The levels are simply names, properties, attributes, etc. And you cannot order them. Hair color, for instance. Do you think that hair color, if we measure using a bunch of levels, that would be nominal?
Yeah.
Yes, because we can't put hair color in order, right? There is no natural ordering to hair color. So it's either black, brown, gray, or gray, brown, black, doesn't matter. There is no inherent ordering. Same with eye color, there is no natural ordering to it. Can you think of one that doesn't have a natural ordering, but it is qualitative?
Couldn't hair be like from light to dark and that's like a property?
Or, now that is ordering. Okay. What's in it?
Lily.
Lily has a very good point. Keep that example. Something else that's nominal, in other words, it doesn't have an order, it's just a bunch of quantity.
Maybe the color of the rainbow. Colors.
Colors, okay. If you're a geek, you probably argue that colors are quantitative. You can't quantify colors. That's so completely split. There is no, level if we say there are simply colors. How about names of countries? If someone came up to you and asked you, well, what country did you visit over the last 2 summers? And you start giving me a bunch of country names, I record everything. Is there a natural ordering to them? No, there isn't one. Keep that in mind also. I'll write that example over here. The good thing we're all here because the rain is about to start. So ordinal has nothing to do with the Catholic Church. Ord, what does ord stand for? O-R-D. What comes to your mind?
Order.
Order. Good. So in other words, it is qualitative, but it has a natural ordering. I'll start with a very lame example, and then we could go to a great example that Lily gave us. So this is my lame example, not chimney, sorry, letter grade. Clearly, it is qualitative, right? No numbers. But does it have a natural ranking or order? Yes, because clearly if I start recording, A is before B, B is before C, and so forth, there is a natural ranking. So hair color, instead of measuring the types of hair color, rather I go for the, what to say, darkness of hair, or level of darkness perhaps, and I categorize it as extremely light, medium, dark, jet dark. The darkest you can get. There is a natural order, correct? When you go from extremely light to jet black, you have a natural ordering, but the data doesn't have numbers. Those are properties, extremely light hair, dark hair, and so forth. Does that make sense? Every day, you guys encounter ordinal data. Wow. It's cool. How?
I agree.
Classes,
You can't use this one.
your schedule, the time,
Time, but that would make it quantitative, right?
but you follow it through.
But still, it is quantitative. It has the scale. Now, with time, I'm measuring it as okay, 5 minutes, 10 minutes, 12 minutes, and so forth, right? Those are numbers that I'm recording, correct? So it wouldn't fall under qualitative, it would fall under quantitative.
The order of classes are in.
Order of classes, okay.
Breakfast, lunch, dinner.
Okay, close. Do we all have breakfast? Some may not. Do we eat? Do we eat fast food? Okay. Do we go to Starbucks? Do this once? Didn't we do this already? Okay, people who go to Starbucks, frequently, you encounter this every day when you order stuff. Who went to Starbucks today? Okay, what did you get? Did you get a drink?
Yes, I got an iced tea latte.
Iced tea latte. Did you just say
In
what's your
order. In order.
name? What did you say?
I said iced tea latte. Iced chai tea latte. My bad.
Okay.
Iced.
All right. So what's your name? What's your name?
Tyson.
You're way off point. So when you went to order, you gave your name. You said, I want an iced tea, chai latte, chai iced tea latte, whatever. But you should have mentioned something else. The size, right? Every day you encounter this. You either say, I want this small, large, venti, right? Size of drink. Small, medium, large, extra large. So if I went and asked each of you, well, what size did you get the last time? Then you'd probably say it's either small, medium, large, or extra large. How about this? The next problem in chapter 2, I'll use that example. But do we agree that there is a natural ordering? Yes, small to large, extra large. But these are not numbers, these are qualities. Does that make sense? Okay. I'm going to erase this part. Quantitative method, we can measure it in 2 levels, interval or ratio. Ratio level is the best level in terms of quantitative data. So what is interval level of measurement? I'm going to erase this also, running out of space. You can have differences between observations. You can order it. It doesn't have an inherent zero or a natural zero. I will explain what that is. And also, we can't express one observation as a ratio or multiple of another is not possible. Okay, these are pretty straightforward differences. You can compute the difference. You can order the observations, and you can't express one as multiple of another. That we will address. Doesn't have an inherent zero. Most commonly used example is temperature. You probably see this everywhere because it is easier to understand. Temperature, it is on a scale, yes. And let's say I have 0 degrees Celsius. Okay. And then I have 17 degrees Celsius. You can convert it to Fahrenheit if you want. This is 32 degrees Fahrenheit. Does 0 degrees Celsius mean no temperature at all? Guys are saying no. Why?
Because it's zero outside, it's still zero outside, if that makes sense, like it's a temperature.
It's a temperature, right? It means very cold, it's freezing, right? It's cold. We're not saying that there is no temperature at all, but we're saying it's cold. 17 degrees would simply mean there is some warmth or temperature. It's a temperature. But if I had two observations, I can compute the difference between the two. Correct. I could say a 10-degree change here can be compared to a 10-degree change there. That's possible. Ordering, possible. One observation as a ratio or multiple of another. We're not talking about algebraically. Rather, we are talking about things from a logical sense. Could I say that 27 degrees Celsius is, exactly two times warmer than 17 degrees Celsius? I should have picked an easy example. We have 30 degrees Celsius, 15 degrees Celsius. Could I say 30 degrees Celsius is twice as warm as 15 degrees Celsius? Is that the case? Always? How many of you say yes?
It really depends. I mean, if it's fair, if you switch it to Fahrenheit, it's not. But
Well, Fahrenheit is linearly related to degrees Celsius, right? They're directly related. Let's say Fahrenheit. We know 30 degrees is from Chicago, 30 degrees. And then we have 90 degrees Fahrenheit. So will I say that 90 degrees is numerically, it is 3 times. In terms of heat, is it exactly 3 times? Could you logically make that argument? Don't think about it from a numerical perspective. From a logical perspective, is it 3 times as warm as 30 degrees Fahrenheit? No. So that's what we mean by an interval scale. You can make sense in intervals or differences, but you cannot make sense if you put it in a multiple ratio. That 0 degrees Celsius is the absence I should have just said not an inherent 0. Because 0 here doesn't mean 0. 0 should mean 0, period. But that's not the case. It doesn't mean 0. I'll pull up some examples from the text on interval data. Ratio, anything or everything that interval is not, ratio is in some cases. So you can order, you can have differences. It has an inherent 0.
I have a question.
Yes.
So like before, did you say 19 degrees Celsius or Fahrenheit?
Fahrenheit.
Oh, okay.
Fahrenheit. would be allowed.
Yeah, I thought you said Celsius, so I.
Yeah, so I switched it to Fahrenheit so that you guys can understand better. Okay, the presence of an inherent zero, in other words, when we say zero, it means zero, period. We can put it in order, and one is a multiple of another. Weight, for example, the weight of an individual. When you say, okay, I am twice as heavy as my sister, right? Or you could say the length of your hands, my length is about 1.6 times the length of someone else's, right? So one observation could be put as a multiple of another observation. Naturally, you have numbers, so it is quantitative. Has an inherent zero. Think of it this way, suppose you have a bunch of bags of sugar, right, that people bring in at the pantry. And as they bring in, one person gives you 10 kilograms, another 20, and then one keeps on going. One person comes up and hands you an empty bag. What does that empty bag mean? No sugar, right? Zero sugar. So there is an inherent zero. Zero means zero. Does that make sense? So when I record zero, I actually mean nothing. So when people bring in that bag of sugar, I'm writing, okay, 10, 12, 20, 24, and all of a sudden, this person gives me an empty bag, so I'll record it as zero. Does that make sense? That's what we mean by an inherent zero. Zero means nothing, logically. Does that make sense? So here, I can't make that argument. When I record 0 degrees Celsius, I'm not saying it means nothing, right? It actually means a colder temperature. So this zero is not an inherent zero. Does that make sense?